The focus of this video is like terms. I'm also hoping along the way we'll pick up the vocabulary coefficient, constant, variable, expression, and equation. That's the vocabulary I want you to learn as well as we go through this video. First of all, we want to look at the difference between expression and equation. Expression does not have an equal sign. So it does not. An equation, as you can see, does have an equal sign. And you should be writing this down as I write on the board. The next thing we want to do is we want to look at examples of variables, examples of coefficients, and examples of constants. So we're going to pick apart the expression example and the equation example to learn the other vocabulary. First of all, a variable is a symbol that represents a number. So I've just circled all of the variables. The constant is the number that stands alone, so it's not being multiplied by a variable. It's on its own. And right now I'm putting a little box around each of the constants. Those were all of the constants in that expression. We also want to look at coefficients. The coefficients are the numbers in front of the variable. Every single variable has a coefficient. So we're going to go through and we're going to look at every variable and identify its coefficient. The coefficient of x is 4. The coefficient of x here is 2. The coefficient of y is -4. The coefficient of m, we don't see it, so it's a 1. That's 1m. The coefficient of x is 3, and the coefficient of -m is -1. Now let's look at the equation, and we'll also circle examples in the equation. In the equation, the variables are this x, this y to the power of 2, this y to the power of 2, and the final y to the power of 2. The constants are the numbers that stand alone and they do not get multiplied by a variable. So it's the -7, the +8, or the +7 and the +8. Those are all the constants. And then the coefficients are the numbers in front of the variable or the number being multiplied by the variable. So that would be the 5. That would be the -3. The coefficient of y squared is 2. The coefficient of this y squared is -1. And the coefficient of this y squared is also -1. Every variable has a coefficient. Let's go ahead and write these words down with examples. So we're going to start with variable. And the variable is a symbol that represents a number. It can be any type of symbol. Commonly we use x. So you might have 2x. You could also use, instead of 2x, maybe you want to use a tree as your symbol. So we could have 3 and then the symbol tree. It could be anything. It could be, I don't know, maybe you want your symbol to be a watermelon that's had some of it eaten. We got a watermelon. It could be a Y, could be a Z, could be an M. More commonly, we use letters because it's a lot easier than drawing a whole object every time. It'd be really hard to write an equation and have to, at each new level when you're solving it, draw a watermelon again and again and again. It's too much detail. But anything that's a symbol is a variable if it represents a number. In addition to variable, the other vocab word we looked at was a constant. And a constant is a number that stands alone. A number that stands alone. So for example, The constants in this example would be 3, 8, -3, and 2 because they don't have a variable that they're being multiplied by. They stand alone. Then we get to coefficient, and I like to list some other words that start with coefficient. How about copilot, cooperate, co-teacher, co-worker, and I want to highlight this co in front. Co means with or together, so it works with something else. Coefficients are numbers that work with something else. They're always attached to something else. So a coefficient is the number in front of the variable. And then in parentheses, I'm going to write the number being multiplied by the variable. So if we look at the example that you already wrote, the coefficient would be the 2 in front of the x. It would be the -4 in front of the y. And those would be the only examples because the 2 is being multiplied by the x. The -4 is being multiplied by the y. Let me give you another example. Let's say you had 5 is a coefficient, 7 is a coefficient, -3 is not, it's a constant. 20 is a coefficient. Every variable has a coefficient. So the coefficient of -x is actually -1. The coefficient of y is +1, and the coefficient of the last y is a -2. So every variable has a coefficient. There's always a number in front of the variable, or a number that's being multiplied by the variable, and it works with the variable. We are ready to look at the difference between an expression and equation, look at some examples. You'll see the directions at the top, and we'll look at A first. I'd like you to write these down and try it on your own, pause the video, and then play when you're ready. So A, hopefully you've already done that, and the first one is an equation. Letter B, there is no equal sign, so this is an expression. Letter C, there is no equal sign, so it's an expression. And letter D is an equation because there is an equal sign in it. On this page, we also want to look at what a term is. A term is anything that's separated by an addition or subtraction sign. So 3x is a term, 9 is a term, x is a term, 2x is a term, and 4 is a term. All of these are terms because they are separated by an addition or subtraction sign. So in the next example in B, 4x is a term, 2y is a term, 8 is a term, and 2m is a term because all of these are separated by addition or subtraction. Now that we've defined what a term is, we want to think about what like terms are. Like terms are terms that contain, or you could say have, terms that have the same variables with the same exponents. You'll understand this better as we go through the examples. Letter A. The x and the x, the -5x and the 3x, those are like terms because they both have the same variable, x, with the same exponent or power, which is 1. And then what you do is you take the coefficients, -5 and 3, and you combine those. -5 and 3, we get -2, so we have -2x. 7 is a constant, 2 is a constant. They don't have a variable attached to them, so those are like terms. You cannot combine -2x and 9 because those are not like terms. Example B. 9x and -2x are like terms because they both have the same variables with the same exponent. 9 minus 2 gives us 7. You'll see that I took the coefficients and I subtracted 9 minus 2. -5y, there's no term that is like this, so I just copy it down. And then I finally can combine the two constants. 15, that's positive, and a -13 yields a +2. None of these are like terms, so that's as simple as it gets. Right now we are just simplifying expressions. 2x and -2x are like terms. 2 minus 2 equals 0. Those are 0 pairs. So you're left with 0x. 0x, you don't even have to write it. There's nothing left. And then we can combine 4y and -5y because those are like terms. We get -1y. And then finally, the constant 15 is on its own. This coefficient of -1 can also be written as just negative. So -y. When it's a -1, you can also write it as a -y. Letter D. Again, we're looking for like terms. 20y and -50y. We get -30y. Then we have -4x and a +2xy. Now, some people would say, well, these are like terms. They would claim that because they both have the variable of x with the power of 1. However, not all of their variables are the same. The 2xy has a y, whereas the -4x does not have a y. So these actually are not like terms, even though some people might think they are. They're not like terms. So the only like terms that you can combine in this example are the 20y and the -50y. Letter E. It gets a little more complicated. So now what we do is we look at this and you might say, right, they all have x's and y's, so they're all like terms. That is not true. You have to individually look at each piece. You'll see that 11x squared y and -5x squared y have an x to the power of 2. 7x to the third y has a power of 3 on the x. So this does not go with these other two. These two have a y with a power of 1. So these two are like terms. So we get 6x squared y when we combine them. We take the coefficients and we take 11 and we subtract 5 and then we're left with 6x squared y. And then you just have to add on the 7x to the third y. These are not like terms, so that's as simple as it gets. Letter F. Once again, we have to look at this carefully. So we have a y and then an x squared. And we look over here and we have a y and an x squared. What I want you to notice here is that order does not matter. This is a power of 2 on the x. This has a power of 2 on the x. This also has a power of 2 on the x. There's a power of 1 on the y and there's a power of 1 on the y. So those are like terms. So we combine the 18 and the 20 and we get 38x squared y. The order doesn't matter here because of the commutative property of multiplication. Then we copy down the -33y squared and the 4x. None of these are like terms, so that is as simple as it gets. Could have also written this as 38yx squared minus 33y squared plus 4x. Same thing. And I'm going to save the rest of the problems for the next video.